Activity sampling. The questions of how people spend their work time or how equipment is utilized will be addressed in this unit. An activity sampling study consists of a large number of observations taken at random intervals. In taking the observations, the state or condition of the object of study is noted, and this state is classified into predefined categories of activity pertinent to the particular work situation. From the proportions of observations in each category, inferences are drawn concerning the total work activity under study. As an oversimplified example, if a group of housekeeping workers are observed to be waiting in a third of the observations made of their activity, we might draw the inference that better scheduling and job preparation or more effective supervision, rather than an increase in the number of housekeepers, represent the most fruitful areas for improvement. Other questions an activity sampling study may help answer include: what percent of the time are our registered nurses involved in paperwork? What is the percent utilization of our present copiers in the hospital? Let's go back to our housekeeping example to show how these activity percentages are determined. If a total of 3,000 observations were made in the activity sampling study, and 1,000 of these observations were of housekeeping workers waiting, then we are able to state with a known degree of confidence and accuracy that 1/3, or 33 1/3%, of the housekeeper's time is spent waiting. Of course, there are other ways to collect data that will permit activity percentage calculations. Instead of random sampling, we may make direct time measurements with a stopwatch, or we may ask each employee to keep a time log of their activities. Activity sampling has some advantages over the direct time study and time log approaches. In general, the positive features of activity sampling include lower study costs than direct time study. The observer does not have to be a management engineer. In fact, the supervisor of the work group may be the most qualified to observe. No stopwatch is required in an activity sampling study, which may appear less threatening to the workers, resulting in fewer human relations problems. Compared to the employee time log approach to data collection, activity sampling can result in significantly less employee-based bias. Let's take a short break. Please take time now to write down some of the areas in your department where the results of an activity sampling study would help you better identify problems and be a more effective manager. Let's stop the tape for a few minutes while you write down these problem areas. Bring your study ideas to your next training conference or manager's meeting. Discuss and refine the problem statements further. Hopefully, you are now curious about how to make an activity sampling study in your department. You already have some practice in accomplishing the first step in the activity sampling procedure, which is define the need for the study and determine the type of activity data you wish to measure. An example might be,
I think our registered nurses are doing too much work that could easily be done by less qualified and less costly personnel. I wonder what % of the day is devoted to these non-professional tasks.
The next step will involve getting support as well as gaining the cooperation of your employees. Your hospital's administration should be advised of the need for the study and their approval requested. If available, the management engineer should be brought in for technical support. Your employees' cooperation is important to the success of the study. Explain the purposes of the study and ask for their help. Step 3 is to design the study. It will usually be necessary for the hospital manager to get some technical assistance from the management engineer or other person in the technical staff area. Designing the study usually involves the following procedure. First, make a preliminary survey to list the work or equipment categories on which you wish to measure time percentages. An estimate of the activity percentage of greatest interest in the study will also be made. Next, refine your preliminary list of activities. It may prove useful to have letter or number codes identifying each work activity. An illustration of the general activities used in a nursing study is these general activities were further broken down into sub-activities. The sub-activity for just one of the general activities looks like this. In like manner, sub-activities were defined for each of the other general activities. Numerical coding, in this case, was used to make the data as recorded compatible for computer analysis. The required number of observations should now be determined. This number will depend upon how large the activity percent is that you wish to measure and the study accuracy you desire. As we will soon see, formulas can be used to determine the necessary number of observations. However, tables and charts are available that permit rapid lookup of the required number of observations and greatly simplify the task. This formula represents the relationship between P, the percent occurrence of the activity measured, N, the number of observations, and A, the absolute accuracy. The 2 in the expression indicates that the formula is for 2 sigma limits, or about 95% confidence. Now, let's use this expression to solve a number of observations problem. If our activity under study is estimated to occur 20% of the time, and we want the true percent to lie within plus or minus 4% from that 20%, how many observations should we take for 95% confidence? Substituting these values in our expression and squaring both sides, then rearranging, we find that we should take 400 observations. This means that we can be 95% confident that the true percent of our activity under study will lie within the range from 16% to 24%. The next step in designing the study will be to develop the observation logistics. Questions like these will need to be answered. How many observations will be made per day of the study? If, as we have calculated earlier, the total number of observations required is 400, and the study length is 20 days, then 20 observations should be made each day. Next, we need to know the usual number of observations that will be made each trip. If, for example, we will usually get 5 observations on each trip, then we will require 4 trips each day of the study. Other observation logistics need to be determined at this time. The route the observer will follow should be established. The data collection form should be designed. It may be as simple as the tally sheet illustrated here, or more complex, such as the observer's record shown here, or specifically designed for data analysis and reporting on the computer, such as the stylus-punched computer card shown here. A Hewlett-Packard Palm-Top PC is shown here. This shirt pocket-sized handheld computer is used in one of the state-of-the-art computer-aided work sampling systems available now. An example of a computer-aided work sampling report is illustrated here. A total of 122 trips were made in this study, resulting in 754 observations. The observer should be trained and allowed to practice data recording in order to develop both consistency and accuracy. Once the preparatory and study design steps have been accomplished, you are ready to collect the data by recording your observations. Make sure all employees associated with the study fully understand the purpose of the study and how the data are to be collected. The observations should be made at randomly selected times, although fixed time interval studies are permissible under certain conditions. Drawing numbers from a hat will work. However, it is more convenient usually to use a table of random numbers available in most mathematics handbooks. Make your observation instantaneously so that you are not biased one way or the other as you approach the employee whose activity is to be recorded. Make the observation from some constant geographical point at the instant you reach the spot. After all of the observations have been collected, you are ready for the final step in conducting the activity sampling study, analyzing your study results and developing conclusions and recommendations for improvement. The percent occurrence for a given activity will be equal to the ratio of the number of observations when that activity was observed to the total number of observations. For example, if nursing personnel were noted to be walking on 50 occasions and a total of 400 observations were made, our best estimate of the percent for walking would be 12.5%. Here we show an illustration of a summary report of an activity sampling study of registered nurses. The major conclusions of this study were that the RNs performed too much work that could and should be performed by auxiliary personnel. The percent of time for communications also seemed very high, and an area to improve through the use of other methods improvement techniques. The activity sampling technique has proved to be of significant help to the hospital manager and supervisor, particularly in the problem identification phase of an improvement project. Activity sampling is an excellent and usually low-cost method of seeing how employees spend their time and how equipment is utilized. However, it should be stressed that activity sampling is not a detailed methods improvement technique, nor is this sampling procedure as precise as a technique involving continuous observation, such as in a continuous time study. Activity sampling may be a useful technique to apply in your department. The results from such a study can give you, the manager or supervisor, an excellent bird's-eye view of your group's operation. Strengths and weaknesses will be identified, not on the basis of hunches or intuition, but on numerical results. To conclude this unit, let's look at a few of the hospital functions that have successfully used activity sampling. Nursing is one of the direct patient care areas that has benefited from activity sampling. In addition to determining work activity percentages, as we have seen earlier, sampling has been successfully applied to the determination of quality of patient care indexes. Activity sampling was used to assist in the facility enlargement and layout of a health clinic pharmacy. The study revealed that a nearby cast room was used only 8% of the time. The cast room activity was transferred to another department, thus freeing additional space for the pharmacy expansion. Improvements in other hospital functions have resulted from effective use of activity sampling study results. Laundry, dietary, physical plant, the laboratory, and medical records, to name just a few. In fact, anywhere in your hospital work is done, or facilities or equipment is utilized, the activity sampling technique can be used. You should now have a good idea what activity sampling is, what steps are required in conducting the study, and how the results can help improve operations. How can activity sampling help you in the management of your area? Get out the list of areas in your department where the results of an activity sampling study would help. You may now want to add some areas to this list that we started earlier in the unit. A quote from Lord Kelvin provides a fitting conclusion to this unit.
I often say that when you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely, in your thoughts, advanced to the stage of science, whatever the matter may be.